So good evening to all. Good evening, students. Just let me know in the chat box that whether am I audible and visible to all of you. Can you able to hear me? Can you able to hear me? So am I visible and audible to all of you? So I think we can start the class now. Okay. So good evening once again to all of you. So my name is Anandi and today we are going to solve some questions on the topic aldehydes, ketones and carboxylic acids. Okay. So before moving on to the questions, let me summarize the topic which we have studied in the previous classes. Okay. So we were discussing about the preparation of aldehydes. So under the preparation of aldehydes, we have studied Rosenmann's reaction, which is used for the preparation of aldehyde from acyl halide using Rosenmann's reagent, which is palladium barium sulfate. And coming to the next reaction, we have prepared aldehyde from nitriles using Stephen's reagent, which is SnCl2 and HCl. And okay, okay, fine. So the second is the preparation of ketones. So under the preparation of ketones, we have discussed about the preparation from acyl halide using dialkyl cadmium. Okay. And then secondly, we have used the nitrile part again using Grignard reagent. We have prepared the ketone of formula RCOR. And the third preparation is the Friedel-Crafts alkyl acylation reaction. Okay, and RCO is the electrophile here. And this reaction is one of the example or the reaction for electrophilic aromatic substitution. And here the RCO electrophile goes and attacks one of the carbonyl carbon. Okay. And also we have discussed some physical properties of aldehydes and ketones. Mainly aldehydes and ketones, they are having the higher boiling points compared to hydrocarbons and ethers of comparable molecular masses. Okay. And coming to the chemical properties of aldehydes and ketones, we discussed the nucleophilic substitution reaction, where the nucleophile goes and attacks the carbonyl carbon, and we got the tetrahedral intermediate kind of thing, and at last we got the final product using hydrolysis. Okay, and this is the nucleophilic addition. And next we have discussed the catalytic reduction. So reduction using hydrogen in presence of platinum or nickel metal as the catalyst. The CO part is getting converted to CHOH. And the second reduction is Clemmensen reduction. In the Clemmensen reduction, we used zinc, mercury, and HCl as the reagent. And in the Ulf-Kirchner reduction, NH2, NH2, and KOH were used as the reagent. So in both the reactions, the CO group is getting converted to CH2. That is, we are getting the hydrocarbon from the Clemmensen reduction and Ulf-Kirchner reduction. Got it? And coming to the oxidation reaction of aldehydes and ketones, and aldehydes and ketones in oxidation gives carboxylic acids, RCOH. So the oxidizing agents can be nitric acid, potassium dichromate, and potassium permanganate kind of reagents were used as the oxidizing agents here. And also we have discussed two tests which are used as a test for aldehydes, right? One is the tolerance test, the other one is the Pelling solution test. And in the tolerance test, we used ammoniacal silver nitrate solution as the reagent. And this reagent on treatment with aldehyde, both aliphatic and aromatic aldehydes can be used. Okay, we get the carboxylate ion. That is, aldehyde is getting oxidized to carboxylic acid part. And we can identify that the system contains aldehyde by seeing the silver mirror kind of formation around the walls of the container which we are using. And this is the tolerance test. And coming to the Pelling solution test, copper ion was used, copper 2 plus ion was used here. And Pelling solution A and B we used to have, and we have to mix those two solutions. And to that solution, if we add the aldehyde, so here only aliphatic aldehydes will respond to Pelling solution test. Aromatic aldehydes cannot be used. Okay. So if the aldehyde is aliphatic aldehyde, then that aldehyde will be converted to carboxylate ion or carboxylic acid, and the Cu2O is formed as a byproduct, and it is formed as a red-brown precipitate. By seeing that precipitate, we can confirm that the system is having aliphatic aldehyde part in it. Okay, so this is what we have discussed in the classes. This is a summary of the thing, and now we can move on to the questions. You can see the question number 1 on the slide. So I think you can see the slide, right? If you can see the slide, just type S so that I can understand that it is visible to all of you. Okay. So you can see the question on the slide. Identify the major product obtained in the following reaction. So you have to find out the major product. I'll give you some seconds. Try to find out the answer and let me know in the chat box. So an aldehyde or an aromatic aldehyde and ketone containing compound is given in the reactant side. And the ammoniacal silver nitrate solution is there. And this on heating forms the product. So just now we have seen, no? So we do get 2 to 3 products. And what is the major product that we get from the given reaction? So 4 options are given to you. Just try for it and let me know in the chat box for the correct answer. Then we'll discuss. Okay. So this is used for the tolerance reaction, which is being used for the test for aldehydes, right? So here, just a second. Okay. So here aldehyde only gets converted to carboxylate ion. So this is the CHO part, that is the aldehyde part. So CHO will be converted to COO minus, right? That is the carboxylate part, carboxylate ion part. So RCHO will be converted to RCOO minus ion. No? So this is the ketone and this is the aldehyde. So only aldehydes respond to tolerance test. Since this is the ammoniacal silver nitrate solution which is being used for the tolerance reagent. Got it? So CHO is getting converted to COO minus is the answer, and this is given in option B, right? That is given in option B. So in A, if you see, the aldehyde is getting converted to alcohol. No, that is not the answer. And here, aldehyde part is getting oxidized in option C. Ketone part is also getting reduced to alcohol. No, that doesn't happen. And in option D also, both are getting reduced to alcohol. No. So this is the oxidation reaction, and only oxidation happens. That too, only aldehydes gets oxidized to the corresponding carboxylate ion. But its option B is the correct answer, and this is the major product for the given reaction. Got it? So do you have any doubt here in this question, or you want to ask anything? You can ask. Otherwise, we'll move on to next question. So you can see question number 2 on the slide. So you have to complete the following reaction. So cyclohexanone is given here as product A, and compound A, and this compound A on treatment with HCN forms a CnOH containing compound which is called as cyanohydrin. Is called as cyanohydrin, and this cyanohydrin on reaction with concentrated sulfuric acid and on heating gives C. So we have to find out the compound C here. So how to get compound C? So acid contains H plus, right? All the acids contain H plus. So here the lone pair of oxygen, 2 lone pairs on oxygen we have, and 1 lone pair of oxygen will go and protonate the acid. Okay. So we'll get the OH gets protonated and we are getting a OH2 kind of intermediate, and here Cn is present. And to neutralize this, so one of the hydrogen from this part goes out by giving the electrons here, and this OH2 goes out. Okay, so from this we'll get a double bond here in this compound, and where Cn is attached, and OH2 goes out as H2. And again, this on treatment with the same sulfuric acid part or on heating forms COOH. Cn is getting converted to, or Cn is hydrolyzed to COOH. So this is compound C. So basically what is happening? Alcohol part is protonating the H plus from the acid, and the water is removed and the elimination occurs, and we are getting a double bond there. And on hydrolysis, this cyanide group is getting converted to carboxylic acid. So basically this is the answer. So it is given in option C. So option C is the correct answer for this question. So do you have any doubt here? Have any doubt? You can let me know in the chat box. So always remember that cyanide on hydrolysis forms the carboxylic acid, and OH always protonates the acidic part. Okay. So we'll go for so which part is not clear to you? JND Vishakhapatnam. So just protonate the, so H2SO4 contains H plus and HSO4 minus, right? H plus and HSO4 minus ion. So the lone pair on oxygen first protonates the H plus and H. OH is taking the H. So that this OH becomes OH2. Okay. And this HSO4 minus, which is remained there in the concentrated HSO4 part, goes and attacks the hydrogen which is next to that, which is next to the OH2 containing carbon. So this is the carbon which is next to the OH2 containing carbon. No, it goes and takes that hydrogen, and the electrons which is present in this bond comes here and forms the double bond, so that the OH2 leaves out as H2. Got it? So H2O is removed and the double bond is formed here. And this compound on heating forms the carboxylic acid, which is COOH. And it will be converted to COH. Is this clear now? Is this clear now? Yes. Thank you. And we'll go for the next question. That is question number 3. So question number 3 states that the incorrect method to synthesis the benzaldehydes. So 4 different methods are given here for the preparation of benzaldehyde, and we have to find out the incorrect method to synthesis the benzaldehyde. So can you find out it? We can go for the first preparation. Let's go from the first. So we are having cyanobenzene. So cyanobenzene is first reacting with CH3MgBr. So take cyanobenzene. This is the cyanobenzene C triple bond N, and this is going to react with the Grignard reagent of formula CH3MgBr, followed by hydrolysis. So what happens here basically? So first on treatment with CH3MgBr, the negative part, partially negative part, which is CH3, goes to the carbonyl, the carbon, not carbonyl carbon, the electrophilic carbon, that is CH3 here, and MgBr goes to the nitrogen. The positive part goes to the nitrogen. So first we'll get an intermediate like this, that is C double bond N, and here CH3 is there, and here we have added MgBr. Okay. Now this compound on hydrolysis forms, and the whole NMgBr group will be converted to oxygen on hydrolysis. The whole NMgBr part will be converted to oxygen on hydrolysis. So what we will get? We will get C6H5, C, CH3, and double bond O. Got it? So what is this? So this is a ketone, right? This is the R group. This is the R group, R, C double bond O, and this is the R dash. One is phenyl and the other alkyl group is methyl. So RCO R dash. So this is the ketone. So this method is used for the preparation of ketone. So it is not the correct method to synthesis the aldehyde, that is the benzaldehyde. And what is the name of this ketone? The name of this ketone is acetophenone. Right? This name of this ketone is acetophenone. And this is the incorrect method to prepare the benzaldehyde, which is the correct answer for this question. And when you see option B, C, and D, option B is Rosenmann's reaction, right? So this is option B is Rosenmann's reaction, and PDBSO4 is Rosenmann's reagent. And here the Cl will be converted to hydrogen, and we get benzaldehyde from option B. And from option C also, we are using ester and treating this ester with dibyl H. So what is dibyl H? Dibyl H is diisobutyl aluminium hydride. Diisobutyl aluminium. Yeah. So Stephen has given me the answer as option A. So that's great, Stephen. I'm only seeing it. Okay, fine. And in option C, you can see ester is given. RCOR, ester is there, and ester on treatment with dibyl H, which is diisobutyl aluminium hydride, followed by hydrolysis, we'll get H here, no? That OR group will be converted to H and benzaldehyde is formed. And the last reaction is ITAD reaction, where we use chromyl chloride as the reagent using H+. Got it? And here also the CH3 group will be converted to CHO and we get the benzaldehyde from the compound. So option A is the answer for this question. So do you have any doubt here? Yeah, it is ITAD reaction. Good. Visakhapatnam students are doing great. Okay. So I think we can go for question number 4. So do any of you have any doubt here in this question? Okay. We can go for the next question. So given below are two statements. So going to the first statement, it talks about the boiling point of aldehydes and ketones. The boiling point of aldehydes and ketones are higher than hydrocarbons of comparable molecular masses because of weak molecular association in aldehydes and ketones due to dipole-dipole interaction. So just now in the summary part also we have discussed about the boiling point. They are just higher than the hydrocarbons because of the dipole-dipole interaction. And statement 2 states that the boiling point of aldehydes and ketones are lower than alcohols of similar mass due to the absence of hydrogen bonding. Yes. Statement 1 is also true. Statement 2 is also true. So in alcohols, we have the strong hydrogen bonding. Whereas in case of aldehydes and ketones, we do not have hydrogen bonding. So the system which contains strong hydrogen bonding only has the higher boiling point. That is absent in case of aldehydes and ketones, right? So statement 2 is also correct. So option A is the correct answer. Na? So both the statements are correct. So option A is correct. Okay. So aldehydes, ketones. So these both are having lower boiling point compared to alcohols. Okay. But they are having higher boiling point when we compare hydrocarbons and ethers. So this is the order of boiling point. This is the order of boiling point which we have to use to find out the answer. Okay. Got it clear? Shall we move on to the next question? So all these are the previous year's questions. So those are very important and they are easy also. You can solve it. So moving on to question number 5. You have to match list 1 with match list 2. So cyanohydrin, acetal and Schiff's base oxime is given in list 1. That you have to match. So I'll give you 30 seconds. This question is very easy. Just try for the question and let me know the answer in the chat box. Okay. So in the chemical properties of aldehydes and ketones, we have discussed this now. So cyanohydrin. So for the formation of cyanohydrin, which reagent has to be used? For the formation of cyanohydrin, CN and OH containing compound is cyanohydrin. No? Which reagent we used? Which nucleophile has been used for the preparation of cyanohydrin? It is HCN, right? So cyanohydrin is prepared from HCN. And acetal. So acetal is basically the carbon which contains 2 OR groups into it. So that is getting prepared from the 2 moles of ROH, which is alcohol. So from 2 moles of ROH alcohol, we get acetal. So B goes to 3. And the Schiff's base. Schiff's base was prepared from amine. The substituted amine we got no. So from ammonia and its derivatives part, we have studied this. So we get the Schiff's base from the amine and oxime. We are getting the oxime from NH2OH. So this is the match, and then A goes to 4 is given only in option D. So option D is the correct answer for this match. Yes, option D is the correct answer. Good. Good, good. So shall we move on to the next question? Yes. We'll go for the next question. So the correct order of reactivity of phenyl magnesium bromide with the three compounds. So what is the first compound? It is pH means it is C6H5, right? pH is C6H5. C6H5CO. C6H5 is compound 1. C6H5, C6H5, C double bond O, C6H5. This is compound number 1. And what is compound number 2? It is just CH3, C double bond OH, ethanol. Right? This is compound number 2. And what is compound number 3? Compound number 3 is CH3, C double bond O, CH3. It is a propanone. So this is compound number 3. So all these three reactants are going to react with the phenyl magnesium bromide. So the phenyl magnesium bromide is the Grignard reagent. And which is more reactive towards the Grignard reagent? They are asking. So what could be the answer, correct answer for this question? And which concept you have to use here? Aldehydes are more reactive than ketones. So that concept you have to use now. So this is basically the nucleophilic addition reaction where we break the C double bond O bond, where we break the C double bond O bond here and we add MgBr here and C6H5 group to the carbonyl carbon and we get COMgBr and here we get C6H5 and this compound on hydrolysis forms, the whole group will be converted to OH, right? We'll get OH here and here C6H5 and a bond will be there. So this is basically the nucleophilic addition reaction where C6H5 is the nucleophile getting added to the carbonyl carbon. So in this topic, you might have studied this statement that aldehydes are more reactive than ketones. So you can see in the three compounds, the first compound is RCOR group containing compound, which is a ketone. And the second compound you can see the CHO containing system. So it is an aldehyde. And the third compound is also a ketone. So which is more reactive? Which compound is more reactive? Aldehydes are more reactive, right? So second compound is more reactive. So in all the four options you can see second compound is more reactive only in option C. So that is the correct answer. And after this compound 2, compound 3 comes. So why compound 3? Why not 1? So here you can see CH3 group attached to the ketonic part. And here 2 C6H5 groups are attached to the carbonyl carbon. So C6H5 groups are electron withdrawing groups and the CH3 group is an electron donating group to the system. Okay. So electron donating group to the carbon increases the electron density on the carbonyl carbon. Okay. So compound 3 is more reactive. Then comes compound 1. Okay. So option C is the correct answer for this question. Okay. So we'll go for question number 7. What is question number 7? In the given reaction sequence, you have to find out the final product F. Okay. You have to find out the final product F. So it is very easy. You don't have to get scared of seeing the question. It's very easy. Just go slowly. So first a reactant is there. And that reactant is going to get treated with the ozone. That is, you have to do the ozonolysis reaction here. So what happens on ozonolysis? So in ozonolysis, between the carbon double bond carbon, just break the bond, add one oxygen to the left carbon and the other oxygen to the right carbon, you will get the two products. So you will get compound A and B. So what is compound A and B? Compound A is, have to draw the ring and add double bond here. This is compound A. Okay. And what is compound B? So C6H5CHO. So this is compound B. Okay. And this compound A and B reacts with dilute NaOH to give compound C. It reacts with dilute NaOH to give compound C. So here what happens? So this is basically the aldol condensation reaction. So in the aldol condensation, what we do? We have to, this is one of the compound and it is going to react with C6H5, C double bond OH, right? And in the benzaldehyde part, that is in compound B, we do not have alpha hydrogen. And only in compound A, we are having alpha hydrogen. So you have to remove one of the alpha hydrogen from the system and you have to convert it. On conversion, you will get CHOH and C6H5 part here. Okay, the CO is getting converted to CHOH. Okay, this is compound C. And from compound C, you have to eliminate the water and you will arrive at compound D again. So compound C on treatment, that is on dehydration, forms, or I'll put the double bond here. I'll get CH, C6H5 back again. So this is compound D. And we are getting the same reactant here again. And this compound D on again ozonolysis form E and B. It forms E and B. So you have to break this bond. What happens on ozonolysis? Break one of the bond, add oxygen and the another oxygen here to the D compound. So it forms two products. One is this. This is compound D and we are getting compound E. And one more we are getting no C6H5 CHO. So this is same as that of compound B. So that's why they have given E and B here. E plus. And this E, compound E, on treatment with H2 and platinum metal. So what is this H2 and platinum? It is the reducing agent, no? So hydrogen in presence of a metal, which is called as catalytic reduction. And this H2 can reduce both the double bond which is present there in compound E. So finally, what you will get? You will get ketone always forms secondary alcohol, right? So you'll get a compound like this. And in this compound, so this is compound F. And in this compound, we have two OH groups attached to the cyclohexane ring. So what are OH groups? They are alcohols, right? Since we have two alcohols in the compound, and this compound is named as diol. So finally, we are getting diol from the given sequence of the reaction. So option A is the correct answer for this question. Okay. Yes. Option A is the correct answer. So do you have any doubt here in this question? Do you have any doubt here in the sequence? Yeah, it is clear. Good, Vishakhapatnam students. So I can move on to the next question. Then, appropriate reagent for the transformation of para-hydroxyacetophenone to 4-ethylphenol is. So what we are supposed to do? The appropriate reagent used for the transformation of para-hydroxyacetophenone. So what is para-hydroxyacetophenone? First, you have to draw the structure of acetophenone. It is C6H5, C double bond O, CH3. This is acetophenone. And in the para position, para means opposite position to this system. That is, this carbon is the para to acetophenone part, COCH3 part. And here we are having an hydroxy group. This compound is called as para-hydroxyacetophenone. And you have to convert this compound to 4-ethylphenol. You have to convert it to 4-ethylphenol. So this is phenol. So here it is 1, 2, 3, 4. And the fourth carbon, we are going to have C2H5 part. And you have to convert the first compound to the 4-ethylphenol. Now, how to convert this? So, any idea to convert this? Any idea? So can you think of it and let me know in the chat box for the answer? How to convert this? Which is a more effective method to convert it? So this is basically the reduction, right? This is reduction. So it is just the other way around. So you can take this. OH group remains constant in both the compound. Only the COCH3 part is getting converted to C2H5. That is C2H5 also can be written as CH3, CH2, right? So only the C double bond O is getting converted to CH2. C double bond O is getting converted to CH2. C double bond O is getting converted to CH2. So what is the name of the reduction? What is the name of the reduction we use here? So we can convert C double bond O to CH2 using the Wolff-Kishner reduction, right? So Wolff-Kishner reduction is the more effective method to convert the C double bond O group to CH2. That is, it is more effective method to convert the ketonic CO group to CH2 group. Okay, so this is a ketone. In the reactant, we are having the ketone part. And there C double bond O is getting converted to CH2 part. So, which is the Wolff-Kishner reagent from the given 4 option? Which is the suitable reagents? Yes, very good. It is option C. Option C, NH2 with OH minus. So OH minus basically comes from KOH, no? You might have seen in your classes. So that is the reagent which has been used for the conversion of CO to CH2, which is otherwise called as the Wolff-Kishner reagent. So it is very easy. Okay. So this is clear now. We can go for the next question. Identify compound X in the following sequence of reaction. Identify compound X in the following sequence of reaction. So toluene is given. Toluene on reaction with chlorine in presence of H nu forms X, and then X on hydrolysis forms benzaldehyde. This is one of the reactions which we have studied in the preparation of benzaldehyde. Find out the compound X first. I'll give you 15 seconds. Just try to find out the answer first. Very easy. So what is the answer for the question number 9? Is the answer option B? Is the answer option B? Just think of it once again. Option B is not the correct answer. Option C is the correct answer for this question. Okay. So only out of 3 hydrogen which is attached to this carbon, only 2 hydrogens will be replaced by the chlorine. Yes. Only 2 hydrogens are replaced. Yes, option C is the answer. Only 2 hydrogens are replaced by the chlorine and we get CHCl2. And what is the name of CHCl2 and C6H5? This is called as benzyl chloride. This is called as benzyl chloride. This question is very easy, but you have to be very careful in finding out the answer. You should not get confused. Okay. So here only 1 hydrogen is getting replaced. But in the answer, 2 hydrogen should be replaced by 2 chlorine. Okay. So option C is the correct answer for this question. Got it? Then next we'll go for question number 10. So the reaction by which benzaldehyde cannot be prepared. The reaction by which the benzaldehyde cannot be prepared. The same type of question we have discussed the previous slides. So try to find out the option from which the benzaldehyde cannot be prepared. I'll give you 10 to 15 seconds. Try to find out fast. So what about option A? Can we prepare the benzaldehyde from option A? Can we prepare benzaldehyde from option A? No. A is not the answer. A is not the answer. We can prepare benzaldehyde from option A. Yeah, yeah, that is the right answer. Yes, good. So, okay, I'll discuss this question. Okay. So from option A, you can prepare the benzaldehyde because what is the name of the reaction given in option A? So this reaction is Gatterman-Coach reaction, no, which is used for the conversion of direct conversion of benzene to benzaldehyde, where we use carbon monoxide HCl and AlCl3 is being used as a catalyst. So from this, you can prepare the benzaldehyde. And what about option B? Option B, the zinc and mercury is given here, and concentrated HCl is given here. And what is the name of these two reagents? What is the name of these two reagents? They are Clemmensen reagent, no? These two are Clemmensen reagents, which is used for the conversion of C double bond O group to CH2 group. Okay, so these reagents will convert the C double bond O group present here to CH2 group. So you will not get benzaldehyde from that, you will get benzyl alcohol from option B. And from the which is the correct answer for this question. And from option C, you can prepare benzaldehyde because it is one of the very important naming reaction called Itard reaction. And option D is also a name reaction, which is the Rosenmann's reaction. This is the Rosenmann's reaction, from which you can prepare benzaldehyde from benzoyl chloride using palladium barium sulfate and H2. Okay, so only from option B you cannot prepare benzaldehyde since the reactant leads to benzyl alcohol. Okay, is that clear to everyone? Is this clear to everyone? Shall we move on to question number 11? Yes. So consider the following reaction and find out the product A. That's an easy question. You can get the answer. Yes. Yes. So what is the answer for question number 11? Just reply quickly. Just now we have seen. Yes, option A is the correct answer. And what is the name of this reaction? What is the name of this reaction? It's Rosenmann's reagent, right? So it is the Rosenmann's reaction. Yes, very good. Yes. So it is used for the preparation of benzaldehyde. The chlorine will be converted to oxygen, hydrogen, and we get the benzaldehyde from this. Such an easy question. Next, we'll go for question number 12. Which alkene on ozonolysis gives propanal and propanone? Which alkene on ozonolysis gives propanal and propanone? So you have to find out the reactant from which these two compounds are getting prepared. So how to solve this question? How to solve this question? Just count the number of carbons present in the products given in the question. So how many carbons are there totally? 1, 2, 3, and here also 1, 2, 3. So 3 plus 3, we are having 6 carbon. So the reactant should be a 6 carbon containing alkene. Okay, reactant should be a 6 carbon containing alkene. Just check for the 6 carbon containing alkenes in the given 4 options. So you can, A contains 6 carbon and B also contains 6 carbon. C contains only 5 carbon. So this cannot be the reactant. And D contains only 5 carbon and this also cannot be the reactant. So the correct answer lies in option A or option B. So you have arrived at the answer. Huh? Yeah. Option A is the correct answer. So what we have to do? What is ozonolysis? Breaking the double bond and adding oxygen to both the carbons. So break the double bond and add oxygen like this. So in one side CH3, CH2, CH4, which is the propanal, and on the other side you're having CH3, C, double bond O, CH3, propanol, right? So these two are given there in the question part. So option A is the correct answer for this question. And what would be the product you would get from option B? If option B is taken as the reactant, this reactant on ozonolysis, what are the types of products you will get from the reactant given in option B? Can you name the product that you will get from option B. So what are the products you will get from option B? So just break the double bond. Just break the double bond and add oxygen. So what you're getting? You're getting 2 moles of propanol. So what we are getting from this? We are getting 2 moles of CH3, CH2 and CH2. Okay, so 2 propanol we are getting from option B, even though it contains 6 carbon. Got it? So all these are very easy. Next we'll go for question number 13. So the correct structure of the product A from formed in the reaction. You have to find out the structure A from the given reaction. So try to find out. So cyclo X 1 node and queen is given, and the compound on treatment with the hydrogen gas at 1 atmospheric pressure in presence of palladium carbon as a catalyst and in presence of ethanol gives A. So what is compound A? What is compound A? So what is this? What is the name of these reagents? Is this oxidation or reduction? So H2 is used for the reduction purpose, right? H2 is used as a reducing agent, and this hydrogen reduces only the carbon-carbon double bond. Yes, it is reduction. Good. And this hydrogen reduces carbon-carbon double bond faster than the carbon-oxygen double bond. Got it? So carbon-carbon double bond is reduced faster. So what happens on reduction? You have to break the bond, break the double bond and add hydrogen on both the carbon. So what you will get finally? We will get C6H. Yeah, good, correct. So we'll add both the hydrogen, we'll get the compound like this, and this is called as cyclo. And the name of this compound is cyclohexanone. Name of this compound is cyclohexanone. So option B is the correct answer for this question. Okay. So moving on to the next question. Question number 14. The product formed by the reaction of an aldehyde with a primary amine is. The product formed by the reaction of an aldehyde with a primary amine. What is the formula for aldehyde? It is R C double bond O H. This is aldehyde. And what is the formula for primary amine? It is R N H2. So this is your primary amine, which can be represented using the symbol 1 degree. Okay. So what happens on treatment with these two? What do you get from this? You might have come across this reaction in nucleophilic addition, but so finally we will remove this H2O. We used to remove this H2O and we get a final product like this. R, C, double bond, H, N and R you will have to. So what is the name of this compound? What is the name of this compound? Very good. So the name of this compound is substituted amine, or it is called as Schiff's base. So the name of this compound is Schiff's base. Substituted amine is called as Schiff's base. So option C is the correct answer for this question. Okay. So we'll go for question number 15. Which one is most reactive towards nucleophilic addition reaction? So again, you have to use that statement which I have told you for the previous question. That is, aldehydes are more reactive than ketones, right? So that concept you can use here. And with that concept, you have to use one more concept also. Just try to find out the answer and then we'll discuss. So what could be the correct answer for this question? 4 different compounds are given. Aldehydes are more reactive. So in the first compound, it is aldehyde. And option B is the ketone, RCOCH3. So ketone cannot be the answer. And in third compound also having the aldehyde part. Fourth compound also contains aldehyde part. So among A, C and D, which is the correct answer. So in compound A, in option A, so para to CHO, we are having a hydrogen, small hydrogen attachment. And in option C, para to CHO, CH3 group is attached. And in option D, para to CHO, NO2 group is attached. Can you find out the answer? Can you find out the answer? So some students have got the answer. So it is option D. Yes. So how option D is the correct answer for this question? So I told you that this is an example for nucleophilic addition, and which one is most reactive? For a nucleophile to come and attack, the system should be electrophilic. That is, the system should be electron deficient, right? So here hydrogen is neither an electron donating nor an electron withdrawing group. In case of CH3, the group is electron donating. And if CH3 donates the electron to the system, it makes the carbonyl carbon more electron rich. An electron rich nucleophile cannot come and approach the electron rich carbonyl part more effectively, right? But coming to option D, NO2 group is an electron withdrawing group. So the NO2 withdraws the electron from the ring, and the electron density on the carbonyl carbon of the CHO group gets reduced. Yes, very good. It needs electron deficient, right? So NO2 is an electron withdrawing group. So it reduces the electron density and makes the carbonyl carbon more electrophilic, so that a nucleophile can come and attack, or it can come and react with the system more effectively. That is, it is more reactive. Got it? So that's why option D is the correct answer for this question. Okay. And let's discuss one more question for today's class. So this could be the last question for today's class. Try to find out. And the question says like this: acetone is treated with excess of ethanol in presence of HCl, and the product obtained is. Just you have to find out the product on treatment of acetone with ethanol. What is the formula for acetone? CH3, C double bond O, CH3. This is acetone, right? It is treated with excess of ethanol. First, treat this with 1 mole of ethanol. Excess means could be 2 moles of ethanol. First, treat it with 1 mole of ethanol, C2H5OH. Again, it is an nucleophilic addition reaction, right? So OR group is the negative part and H is the positive part. Break the one of the double bond, add positive part to oxygen and the negative part OC2H5 to carbon. You will get one product, that is CH3, COH, and the CH3 is there, and newly we have added OC2H5. Got it? This is the product that you are getting from the 1 mole of ethanol. You are getting option C. Yeah, option C is the partially correct answer, but it is not the correct answer. Okay. So you have to treat this with excess of ethanol, right? So you have to treat this with 1 more mole of ethanol. So treat this compound with 1 more mole of ethanol, that is C2H5OH. C2H5OH. Okay. So here OH from this compound and H from this ethanol leaves out as H2O. Leaves out as H2O, and this OC2H5 goes and attacks this carbonyl carbon. So what you will get? CH3, C, CH3, and OC2H5 is there, and newly a carbon oxygen bond with C2H5 is formed. So this is the final compound we are getting on treatment of acetone with excess of ethanol. Excess means just 2 moles of ethanol you have to do. Okay. So where this compound is present, this is the answer. And this compound is given in which option? Just try, check it and tell me. So 2CH3 group we are having, and 2OC2H5 we are having. So it is given in option D, which is the correct answer. And the name of this compound is, what is the name of this compound? It is a ketal. Since we are getting it from ketone, this is called as ketal. Okay. So from aldehyde, if you get, it is called as acetal, and since we are getting it from ketone, it is called as ketal. So we are getting a gem dialkoxy compound. Geminal dialkoxy. What does mean by geminal dialkoxy compound? What is a geminal carbon first? So to the same carbon, if two OR groups are attached, then it is called as geminal dialkoxy compound. Got it? Yes. So is this clear to you all, or do you have any doubt here in this part which we have discussed so far? So we were able to complete 16 questions on this day, and we can do some more questions in the next class. We can do some more questions in the next class. So everything is clear. Good. Thank you so much for the response I'm getting from Vishakhapatnam students. Thank you. Others are also listening. Some issues might be there. Okay, no problem. Okay, then. See you all in the next class, students. Take care. Bye-bye. Thank you. Thank you all. Thank you. Thank you.